In this video, we will be discussing how to use the quadratic formula to find the roots of an equation. The quadratic formula is something that we can use to find the roots of any equation, so it will work no matter what type of polynomial or quadratic function we have. Remember, we've already discussed two ways to find the roots algebraically, and this would be the third way. The first way we talked about is how to use either sum or product or dots and our factoring techniques to solve for x. So we would factor, set them equal to 0, and then solve. The second way that we've been talking about for about a week is how to complete the square and then solve for x. So that would be turning it into vertex form, and then from there using square roots to find the roots of the equation. Pause the video as needed. Feel free to replay any parts of the video that don't make sense. Remember, this video is yours to watch so that you leave with an understanding of how to use the quadratic formula. Please use this video as notes to complete your classwork for today. Throughout this unit, you've learned several ways to solve quadratic equations. And by solve, I mean find the solutions, find the roots, or find the zeros. The three ways that we've talked about are looking at a graph and seeing where it intersects the x-axis. The second way would be to factor and solve for x. And the third way would be by completing the square using vertex form to solve for x. Pause the video and use whichever technique you feel would be best for the launch question. Press play to check your work. So as you can see, I decided to complete the square to find the roots of this equation. I added c and subtracted c to figure out how to get it into vertex form. You can note right here that I used the formula c equals b divided by 2 squared. I ended up getting 0.25, which then I added and subtracted to my equation. When I wrote the equation in vertex form, I got x plus 1/2 squared minus 1.25 equals 0. And then from there, I solved for x. My solution that I received when I completed the square is right here. So I got x equals negative 0.5 plus square root of 1.25 and negative 0.5 minus the square root of 1.25. Those would be irrational roots. So because of that, I can just leave it in the radical and not simplify. As you can see, this wasn't exactly the nicest completing the square question. The result was not a rational number, and the process was pretty lengthy. So if you didn't want to use all of these decimals and have to keep track of them all, we could also use something called the quadratic formula. The quadratic formula looks like an overwhelming equation, but really it's just a formula that we plug numbers into. So here's the quadratic formula. It's x is equal to negative b plus or minus the square root of b squared minus 4 times a times c, and that whole numerator is divided by 2a. I will tell you a way to remember this tomorrow, but for now, remember that when I'm talking about a, b, and c, I'm referring to equations that are in the form of x squared ax squared plus bx plus c, where my numbers a, b, and c are the values in this type of equation. So don't forget that all we have to do to plug into this formula is look at our equation and see what those numbers are. One key thing that people do mess up is here. This means the opposite of b. So if it's positive, you're going to plug it in as a negative, and if it's negative, you're going to plug it in as a positive. You might want to make that note on your classwork. We're now going to go through one of our polynomials, and we're going to do it the three ways that we know how to factor and solve these. So the first way would be by factoring. So I have x squared minus 6x plus 5, and that is equal to 0. From here, because it's a trinomial, I'm going to use sum and product. I need two factors that are going to multiply to 5 and add to negative 6. So my two numbers would be -5 and -1. Now these are my factors, but they're not my roots. So I have to tee it up and I have to solve for x. So x minus 5 is equal to 0, which will mean that x equals +5. And x minus 1 equals 0, so that will mean that x equals +1. So now I know the roots, and this obviously was the most efficient method for this polynomial. But sometimes we can't factor the expression, so we have to find another way to find those roots, which is where the next two methods come into play. If I'm moving too quickly, please pause the video, copy down method 1 before proceeding to method 2. So now we're ready for method 2, which is completing the square. That's that plus c minus c thing that we just did for that first example up at the top. So here's my equation. I'm going to take x squared minus 6x plus c plus 5 minus c equals 0. Now to figure out what that c value is, I need to remember that c is equal to half of the b value squared. So half of my -6 is -3, and -3 squared, so -6 divided by 2 squared is going to give me +9. So x squared minus 6x plus 9 plus 5 minus 9 equals 0. To finish completing the square, my first three numbers end up being factored into this little squared value. To get this number, you just cut your -6 in half. Then I combine these two to get -4 is equal to 0. Now to finish solving by completing the square, I need to solve for x. So +4 plus 4, x minus 3 squared. I'm now ready to get rid of that squared, so I'm going to take the square root of both sides. Remember, a square root has a positive and a negative answer, so I need to make sure that I include both of them. So x minus 3 equals positive and -4. Now I know what the square root of 4 is, so I'm going to write that down. X minus 3 is equal to positive or -2. My next step would be to eliminate that constant of -3 by adding 3 to both sides. And x equals 3 plus or minus 2. So 3 plus 2 gives me 5. And 3 minus 2 gives me 1. Notice how my answers are identical between method 1 and method 2. It might just seem like method 2 is a little longer because it has more steps. If I went too quickly, please pause the video before moving on to method 3. So for method 3, we're going to use this new equation called the quadratic formula. X is equal to -b plus or minus the square root of b squared minus 4ac all over 2 times a. So the first thing I'm going to do is I'm going to identify in my polynomial, right here, what my a, b, and c value is. So a is equal to 1, because it's 1x squared. B is equal to -6. And c is equal to +5. And now I'm just going to substitute those in. Remember, when we substitute in, we put it in parentheses. So x equals -6. Or if you know that's the opposite of -6, you can just write +6. Square root of -6 squared minus 4 times 1 times 5, because that's a and c, all over 2 times 1. And now we're going to see how we can simplify each part before continuing the process. So for this first one, the opposite of -6 is +6, plus or minus the square root Negative 6 squared is positive 36. And now I'm going to simplify this. 4 times 1 times 5 is 20, all over 2 times 1, which is 2. So now really, if I simplify what's in here, I get 6 plus or minus the square root of 16. Whoops, that's a 16. All over 2, which is just 6 plus 4 over 2 and 6 minus 4 over 2. I'm separating that plus or minus there. When I do that, I can continue on to get each of the roots. 6 plus 4 is 10. 10 divided by 2 is 5. And remember, you have a calculator to help you with these calculations. 6 minus 4 is 2, and 2 divided by 2 is 1. Notice how, again, we got the exact same roots as both of the other methods. It's just this time that equation or that formula was able to help us find them. So here, first you identify A, B, and C. Then you write your formula and substitute. And then you solve and make sure that you have solved all the way through to find your x values. So this first equation, don't get tricked. We're going to use the quadratic formula to solve. However, remember, we can't solve until the equation is equal to 0. So we need to subtract 4 from both sides and get x squared plus x minus 4 equals 0. So now I'm going to write down the equation, which says x is equal to negative b plus or minus the square root of b squared minus 4 times a times c, all over 2a. At this point, I'm going to identify my a value, my b value, and my c value. So a is equal to 1, b is equal to 1, and c is equal to negative 4. When I substitute into this equation, I need to make sure that I substitute in parentheses. So x equals negative 1 plus or minus the square root of 1 squared minus 4 times 1 times negative 4, all over 2 times 1. From here, you can simplify anything that you see. So this would be a negative 1 plus or minus. The way I would handle this messy square root is to just plug this whole string into your calculator all at once without the square root and figure out what goes inside of that square root, which in this case ends up being 17. And that's going to be all over 2 times 1, which is just 2. Here's where I would break my two roots up using the plus or minus. So my first root is going to be x equals negative 1 plus the square root of 17 all over 2. And my second root is going to be negative 1 minus the square root of 17 over 2. I'm going to leave my answers like this because I know, based on the radicand of 17, that these are going to be irrational roots. So there's no point to try and simplify them because I would need to round. Please pause the video, try the next one on your own, and when you're ready, play it to check your answer. Now that you can see my answer, hopefully for the you do, you got x equals 4 plus radical 48 divided by 2 and 4 minus radical 48 divided by 2. Tomorrow we'll talk about how to simplify these answers. If you simplified them, just make sure they're equivalent. And for now, these examples or these answers would be perfectly fine as solutions. Use these notes to complete the next question. You're going to determine the solutions. But now this time, instead of from the launch where we completed the square, I want you to use the quadratic formula to answer the question. Answer keys will be posted for the rest of the classwork, so please make sure that you have completed the rest of the classwork and checked your answers.